we shall discuss the identification of some fibers, because it is very important that we know that a particular fiber has been used. This arises in the case of silk and wool, which are very expensive materials. If the sample is 100% silk and 100% wool, we must find out that it is so. And both happen to be protein fibers which are soluble in 5% caustic soda. So if the material is treated with hot 5% caustic soda, nothing will remain, whereas cotton will exist. And cotton is identified by microscopic test. Cotton fiber is unique in the sense that there are convolutions, natural twist. If cotton fibers are examined under the microscope, one can see these convolutions very clearly. And wool also can be easily identified by scales. No other fiber has got scales as in the case of the wool material. If it is polyester and nylon, microscopic appearance will give a deceptive picture. So we should use chemical test. Nylon dissolves in melted phenol. And polyester dissolves in this methyl salicylate. And viscose rayon is a fiber which has got longitudinal striations in the longitudinal view, and some of the advanced cellulosic fibers are mostly cylindrical. Now we have three types of cellulosic fibers: modal, tensile, bamboo. So identification of this is somewhat difficult because all are cellulosic fibers, and no chemical test is possible because all will dissolve in 80% sulfuric acid. Now let us see how the blend composition of a polyester cotton material, which is widely used, or polyester viscose, is determined. Let us say we have a fabric which contains 67% of polyester and 33% of cotton, or 33% of viscose. Fabric is made, let us denote it by W1. Then this is treated with 80% sulfuric acid solution in cold condition for about half an hour. Then it is washed and its weight is determined, W2. So W1 minus W2 divided by W1 into 100 will give the blend composition. That is the percentage of polyester that is remaining. And the balance is cotton, which has been dissolved out. The drop in weight is due to the fact that the cotton has been dissolved out, leaving the polyester behind. So this is how the blend composition is determined. And blend composition also can be determined by measuring the moisture absorption. Now 100% polyester, the moisture regain is 0.4%. For cotton it is 8.5%. So if it is 6-7%, we can take the weighted average 67 into 0.4 plus 33 into 8.5 divided by 100 will give you the moisture regain of 6733. Now for this, a very simple method has been developed. All that is required is a sample, a balance and an iron box. So the fabric is weighed first and it is pressed with an iron box and it is again weighed. So the difference in fabric weight before applying the weight or the heat and after that W2 into W1 will give you the moisture content. And if you have a calibrated graph, the blend composition and the moisture regain of polyester cotton blend, then knowing the blend composition or the moisture absorption, the blend composition can be determined. So this is, and another very sophisticated test is this infrared spectroscopy, which has been done for finding out the percentage of polyester and wool. That is a sophisticated equipment. And X-ray techniques also can be used for finding out the blend composition, which is one more step, an advanced step to find out the blend composition. But the simplest way of determining the blend composition is the solubility test. Then as regards the testing of the material for count, a certain length of the yarn is weighed, and knowing the length and the weight, the cotton count or the text can be determined. The determination of the work count in the fabric, determination of weft count in the fabric, and GSM is very easily determined by a very simple test. All that is required is a strip 5 centimeter by 5 centimeter. And the fabric can be analyzed by taking this 5 centimeter by 5 centimeter for so many properties. First, the fabric is weighed to get the GSM or areal density as it is called. So, if it weighs W1 gram, 25 square centimeters weigh W1 gram, therefore 100 into 100 So by multiplying this by 400, we get this gram per square meter. Because 100 into 100 is 1 followed by 4 ciphers. So 5 such pieces can be tested to get the GSM. And then in these 5 centimeters, all the ends are removed. So what is left over is a weft yarn. And they are bundled together and then weighed. So the length is 5 centimeters approximately. The weight, let us say, is W1 and W2. The linear density or the count of the warp and the count of the weft can be easily determined. The number of ends also can be counted, which gives the set, fabric set, SETT, which is the number of ends per centimeter or per inch. So we get from one strip all the information pertaining to the fabric, ends per centimeter, picks per centimeter, GSM, count, and thickness also can be measured when the weight of the fabric is taken, because it is a non-destructive test. So 5 such swatches are tested for various properties and the average is taken to get the information. The material is covered using sodium hydroxide and sodium sulfate, soda ash. So before covering the W1 weight, W2 is after that. W1 minus W2 into W1 into 100 will give this covering loss, which is supposed to be around 7%. Then after enzymatic treatment also the weight loss can be determined. After plasma treatment also the weight can be determined, the percentage loss in weight can be determined by using this formula. So these are all some very simple tests which can be done to find out the various losses. And reporting the weight loss is very important in the case of enzymatic treatment or with treatment with enzymes or with sodium hydroxide even. Now let us spend a few minutes on this alkaline hydrolysis finishing for polyester. Now if polyester fiber is treated with sodium hydroxide of 10% concentration for about at 70 degrees centigrade for about half an hour, it undergoes hydrolysis. Hydrolysis is a partial destruction of the material, and weight loss is determined before and after to have an idea about this extent of alkaline hydrolysis. And what happens to the polyester following this treatment? There is a weight reduction. The material becomes finer because surface itching takes place, and polyester is converted to silk because of the removal of some fibers at the edges. So the diameter is something like this. After the treatment, the diameter reduces. That is called weight reduction. So the material acquires more moisture absorption. It can be dyed to a dark shade. It becomes like silk. So taking advantage of all these properties, this finishing treatment is applied to 100% polyester sarees and dress materials. And this improves the handle of the material also. And the handle can be determined by using this Kawabata evaluation system. And one more development that has taken place in handle evaluation is a FAST. FAST stands for Fabric Assessment by Simple Testing. Now, in this system, the fabric is tested for bending rigidity, shear, tensile, then shrinkage. And FAST also gives a chart for the garment industry. This is on the high side, this is on the low side. So the fabric that is tested should remain where. And it gives an idea about the tailorability also, which is the product of bending rigidity and the extension. This information will be useful for the garment manufacturers. And another use of this FAST system is to find out the stability of the finish. The thickness is measured at two pressures. 0.5 kPa, kilopascal, and 50 kPa. So a fabric is tested for its thickness at these two pressures, and the difference is taken as a measure of handle. If the difference is greater, it means that the handle is good. If the difference is smaller, there is no change in the handle. The handle is not that good. But after one wash, if this parameter, that is the thickness parameter, is measured, it gives what is called the retained stability, that is the finish. If there is a big change in the thickness or at these two pressures for a fabric before and after washing, then this stability of the wash is poorer. So by providing this information, the FAST system has been found to be of great use by these fabric manufacturers and also the users. Some information about the sewing thread and factors like seam slippage are discussed. The sewing thread is also a textile yarn in the sense that it is made of three components, 3-ply. In some cases 2-ply yarns are used. So we have polyester core yarns, polyester cotton spun yarns, then filament yarns. And a sewing thread is characterized by what is called as the ticket number. A ticket number is given by 30,000 divided by decitex. And the higher the value of the ticket number, the finer the material. For example, 80 ticket number 100. 100 is finer compared to 80, and it is expensive also. Incidentally, a sewing thread constitutes about 0.1% of the garment. And there are various types of sewing threads which differ in their material and also in their ticket number. The sewing threads are produced to provide seams joining the two pieces of the fabric, and it is very important that after washes this seam should not give way, it should be intact. So there are two things which are important in a fabric in which seams have been put. One is the seam slippage and seam strength. Suppose a fabric is tested for strength and the same fabric is cut into two pieces and a seam is put, and this is tested for strength. This will give a lower value compared to the fabric in which there is no seam. So if we take the ratio of the fabric strength with seam, divided by fabric strength without seam, we get a value called seam efficiency. The seam efficiency, if it is something like 93 or above 90, it is supposed to be good. But it has been found that this seam efficiency depends on so many factors. The type of the sewing thread used, the number of stitches per minute, the tension that is imposed in the sewing thread, and also the type of fabric that is being tested, the construction parameters of the fabric like weave structure, whether it is plain or twill or sateen. So a number of studies have been carried out to find out the effects of all these factors on seam efficiency. Then seam slippage, the fabric is tested and the point at which the slippage takes place and the load which is applied at that point gives an idea about the seam slippage. The higher the value, the better the performance. So here the fabric is put a seam and then a load is applied. And there is also another thing called seam puckering. Now the waviness that is found in the armhole of a garment, that is called seam puckering. Seam puckering is not desirable in a garment because it reduces the appeal for the garment, and a garment which is highly having a puckering effect is discarded. And there are so many factors which contribute to this seam puckering. Number one is the state of the fabric in which seams are put. This is warp, this is weft. So by changing the configuration, the seam puckering may be different. And seam puckering is also affected by the type of the sewing thread that is used, the tension that is applied, and the measurement of seam puckering. This has attracted the attention of so many research workers. There are photographic standards which have been given by AATC standard, American Association of Textile Chemists and Colorists. So we have photograph in which there is no incidence of seam puckering at all, and another sample in which puckering is there. So our sample which is to be assessed for seam puckering is compared with these standards, and then a number is given which will give an idea about the extent of seam puckering there. And seam puckering can also be measured by a surface roughness tester. The severity of the seam puckering can be assessed, and by a computer analysis the seam puckering also can be assessed by using a computer. So a lot of trial and error methods have to be used to avoid the seam puckering. Selection of the pieces for making the seams, the angle at which the fabric is to be cut, and then a seam has to be put, and the experiments which have been performed to control the seam puckering have been performed by many people, and they have found out the optimum conditions to overcome this problem. So seam puckering is a very serious damage which will impair the appearance of the garments and ultimately its sale value. Then laundering. A lot of studies have been done on the laundering of textile materials, dry cleaning and also wet washing. Usually a washing cycle will reduce the efficiency of the fabric because finishes are removed, material shrinks, and its handle suffers, and the number of washes a fabric can withstand is also very important. So here also the Kawabata evaluation system can be profitably used. So some of the mechanical properties like bending, shear, tensile, surface roughness, they are all measured before laundering and after laundering, and the differences that are existing between the fabrics are noted down, and then the efficacy of washing is assessed. So some of the Japanese workers have carried out a very thorough study on all these aspects and they reported their results. So that is how the VAR study has to be conducted. And VAR study gives a very useful information to the manufacturers of the garments and also the fabric producers. So far we have been talking about various aspects in textiles, such as the spinning, then weaving, knitting, and some of the fabric characteristics and all. Today let us discuss something about the fabric studies in the sense that how the structure of the fabrics affects the properties. A considerable amount of work has been carried out on this area for a number of years, and it is the purpose of this lecture just to give you an idea about the work and what further work is required. As I have already told you, fabrics consists of woven fabrics, knitted, then non-woven. While woven fabrics are considered for garments and knitted also for garments, but in certain cases these fabrics are also used in non-apparel sector. And apparel sector. Apparel sector is one where these fabrics are considered for making garments and then they are marketed. Whereas in the non-apparel sector, they are used for, say, filtration, then house construction, and agriculture, then medical. A number of items are considered for use as medical textiles because of the fact that the textile materials have got very good absorbent characteristics. For example, today these bamboo fibers have been marketed. They are nothing but viscose fibers, but endowed with antimicrobial effect. And bamboo has got one very specific characteristic, that it has got a very high elongation compared to even polyester fiber, and it has got very good absorbency characteristics. In view of this, they are most suited for medical textiles, and they can be considered as candidates for, let us say, these pads, sanitary pads, and also materials which are used for treating incontinence. And they are also used in the knitted fabrics, where the functions are to impart comfort. Now, comfort means that the fabrics provide very good absorbing characteristic, and there is no what is called as prickliness while they are worn. They are soft and antimicrobial characteristics. This point is with reference to the bamboo fibers, and the properties which are measured in order to find out their suitability for medical applications are, or comfort characteristics are, air permeability, then thermal resistance, and also OMMC, overall moisture management capability. And there is another tester which has been introduced called fabric touch tester. This fabric touch tester particularly gives information about the impact of the fabric on the skin, whether it provides that smoothness or anti-prickling effect, and it is a very recent addition. In fact, some years ago in Hong Kong Polytechnic, Professor Hu developed this overall moisture management capability tester. This tester gives the complete history of the fabric when a drop of the perspiration is added to the fabric. And when a fabric is taken and a drop of sweat, that is simulated sweat, by taking sodium chloride and dissolving that in water and applying that as a drop, then it is absorbed depending on the nature of the fabric, and there is a top side. This top side is very similar to our skin, because the perspiration is on the body, that is on the skin, and when a fabric is worn on that, it tries to absorb that one. So by putting a drop of this liquid on the fabric, it simulates the skin, and the bottom one represents the fabric which is exposed to the atmosphere. So two sides of the fabric, a drop of water is added. This one is next to the skin, and this is to the atmosphere. So depending on, suppose the water vapor is absorbed immediately, that is the wetting time is very short, it is considered to be very good for the fabric. And most important is how long it takes to come to the back side of the fabric. And the test duration is about 120 seconds, that is about 2 minutes. So we have the absorbing characteristics, say bottom and top, and this gives a very good profile about the nature of the absorption of the fabric. So we get one parameter called accumulated overall transportation index, which plays a very critical role on this OMMC, that is the overall moisture management control. The higher the OMMC, suppose it exceeds 0.8, it is considered to be very good, excellent. So, on the basis of this YMMC, it is possible to classify the fabrics according to their moisture absorbing capabilities or the liquid transmission properties, so called. And a number of studies have been carried out using this YMMC. The effect of fiber, for example, polyester cotton blends, polyester viscose, and wool, then wool treated with enzymes, then cotton fabrics treated with enzymes to improve their absorbency, the effect of the low temperature plasma treatment on the YMMC, the effect of the blend composition on YMMC, for example, percentage of bamboo and cotton, percentage of bamboo and polyester on this YMMC has been investigated in depth, and we have considerable amount of literature available on this. So today our knowledge about these characteristics, comfort characteristics in particular, has considerably improved because of the introduction of this overall moisture management control tester. It can be used very usefully for assessing the performance of a sportswear. Today a sportswear is a knitted fabric, and it should absorb moisture. And to judge the performance of the sportswear, this overall moisture management control tester can be used. And attempts are also being made to confer these comfort characteristics to 100% polyester fabrics, because we know that the 100% polyester fabrics in comparison with 100% cotton fabrics are not comfortable, because they are not capable of absorbing the sweat or absorbing the moisture. But one interesting aspect about this polyester is that polyester wicks better than cotton. Wicking is nothing but the spontaneous taking up of water. Suppose a yarn is immersed in a beaker containing water, due to capillary action the water level increases, and if measurements are taken of the height of the water level as a function of time, you will find that it gives a curve of this nature, this being time, this is the wicking height. So up to a certain level the rate is faster, and afterwards the rate is slower due to several factors such as the gravity and also the evaporation of water from the, say, this bottle containing this distilled water, and because of these reasons there is a change in the wicking rate. But however, materials which are capable of wetting are also called very good materials, because their dyeability will be very good and also their comfort characteristics also will be very good. In fact, there is a close relationship between the parameters, in particular wetting time, bottom and wicking. And knitted fabrics made out of polyester, cotton, viscose, then modal, etc., tencel, all have been studied using this YMMC tester to find out which material performs better, so that this information can be used by the manufacturers of the sportswear. Then this non-woven fabrics. Non-woven fabrics are used in the garments. For example, in a suit, the lining material is nothing but a non-woven material, and even in the shirt, in the collar, the lining material is a spun bonded non-woven material. And non-woven materials are used in non-apparel sector to a very large extent, for laying roads, for filtration, for geotextile, to take care of all these problems during flooding, this embankment, and for all the purposes in the construction of the houses and all that. And a considerable amount of work has been done on non-wovens, say from 1965 or 67 onwards, to find out their potential. And today the so-called wipes are nothing but non-wovens made by a process called hydroentanglement. and polypropylene is used for making these wipes, because polypropylene has got a very low fiber density, which leads to a material having a low lightweight, and if some nanoparticles are applied on these wipes, then they are all the more eminently suitable for use, because they are capable of withstanding or resisting these bacteria. So, a considerable amount of research has been done on these nonwoven fabrics, in particular on these hydroentangled nonwoven for the various applications. And nonwovens are also used in dialysis for certain medical applications. It is being used, and the nonwoven sector is contributing a lot to the textile applications. In fact, the shoes inner layer, then the wadding, so-called waddings, they are all nonwoven material. Now let us talk something about these woven fabrics and the structure of them. Textile materials are like engineering materials, except that they are not that hard as steel or other metals, but they are more flexible. But one very interesting aspect is that if steel is made as fine as cotton fiber, and if cotton and steel fibers are tested for strength, it is noticed that cotton gains strength compared to the steel fiber. So that shows the superiority of the cotton fiber over steel. And a woven fabric has got a structure. Some years ago, the structures were represented by terms such as plain, then twill, sateen, then in twills there are several types, say 2 up 1 down, 2 up 2 down, 3 up 1 down, or 4 up 1 down, as the case may be, and sateen also, 5 and sateen, 8 and sateen, 10 and sateen. Plain means there is no variation in that, and even in twill we have so many things: a regular twill, irregular twill, right-handed twill, left-handed twill. So many versions are there, and in sateen also we have irregular sateen. And on this fabric structure, a considerable amount of work has been done, and F.T. Pierce was a person who gave us what is called the fabric mechanics. Or called geometry. And two types of mechanics he has given. One is the descriptive, the other is a mechanistic. In the descriptive one, it just gives a relationship between the various parameters. Now, talking about a woven fabric, a plain woven fabric, we have certain parameters like, say, the modular length, then pick spacing, crimp, in both the directions, that is in warp as well as in weft, and diameter of the yarn. So in the descriptive model, we have the relationship between most of these parameters. C is equal to L minus P divided by P. I mean a general formula where percentage crimp is C, L is a modular length, P is a pick spacing. And these relationships were postulated assuming that the yarn is circular in diameter and the material is very flexible and all. It is not rigid. So, and it is incompressible. So, like that, so many assumptions were made, and then these relationships were put forth, and they are quite useful to calculate one from the other. Thickness can be calculated, and crimp can be calculated. From the crimp and the pick spacing, the modular length can be calculated. But in the mechanistic model, it is very useful for predicting the mechanical properties of the fabric, whereas the descriptive model has got certain limitations, and it is very difficult to find where this fabric mechanics changes from the descriptive model to the mechanistic model, or that line which divides these two. So, a considerable amount of studies has been made using this Peirce's model for predicting the bending, shear and tensile properties by various research workers, and they used various techniques also for predicting. One is the force method, the other is the energy method. Energy is a scalar, force is a vector. So, by using the principles of the energy, that is the work done when a material is pulled, it does some work. So, the work done is equal to the energy. So, based on this premise, so many relationships have been put forward, and the properties of the fabrics have been predicted knowing the structure of the fabrics. The one is the experimental values, the other is the measured values or the predicted values. So, even for a yarn, we have the experimental value, we can predict by a statistical relation even, or a geometrical relation, or a mathematical model. It is possible to do so. A mathematical model is nothing but a relationship. For example, the simplest mathematical model that one can think of is the circumference of a circle. Say 2 pi r or pi d, where pi is 3.14, a constant, or 22 by 7, and d is a diameter, maybe centimeter, millimeter, or whatever it is. And it is possible to predict the circumference of a circle using this formula. It is also possible to measure the circumference by taking a tape of and then finding out the distance from this point to this point. And if we consider the measured value and also the predicted value, they are exactly the same. There is no change, or the percentage difference is very little. So, this is what is to be borne in mind when models have been developed to predict certain things. And prediction is very much necessary, because without making a fabric or without making a yarn, it is possible to have an idea about their characteristics. And it helps in designing the fabrics also, the prediction of a certain parameter from the basic, say, the ideas and all that. Now, even in the case of the fabric, many studies have been done to predict the tensile properties, the bending properties, compressional properties, then shear. And during the year 1965 up to 1968 or 70, Professor Grosberg at Leeds University concentrated more on fabric mechanics, and side by side Professor Hurl in Manchester also dealt with the various aspects of the fabric mechanics using energy methods. Earlier force methods were used, and it was found that the force methods were very cumbersome for predicting the property and energy methods are very easy to apply. Well, that was the beginning of using the computer for predicting the various properties of fabrics called CAD, computer aided design. So today the computer, if some models are being used, they are capable of giving the properties of the fabric such as tensile, bending, compression and shear, and also the handle of the fabrics, because the handle is nothing but the mechanical properties of the fabric such as bending, shear, compression and shear, and also the surface properties such as the surface roughness. When we have all these properties of the fabrics, it is possible to have an idea about their handle. In fact, some mention was made about the Kawabata evaluation system, which is used for measuring the handle of the fabrics. Handle of the fabric ranges from total handle value, as it is called, from 1 to 5. If a fabric has got 5 means it is having excellent handle. If it is having 1 means very poor handle. And this is dependent on the various mechanical properties of the fabrics which are measured. And finally, we get one overall value called THV, that is total handle value, which has got a lot of meaning in that. In fact, the fabrics are exported in Japan and other countries on the basis of this total handle value. And Kawabata evaluation system is a very useful system for assessing not only the handle, but the effect of finishes on the handle of the fabrics, effect of certain treatments such as plasma treatment or nanoparticle treatment or some chemical treatment such as mercerization or biopolishing or whatever it is. In fact, it is a very versatile system which has got the potential of giving us an idea about the handle of the fabrics following several treatments. Even for the industrial fabrics or the non-apparel fabrics as we call them, they can be used to find out the various mechanical properties, because there are 4 groups in this Kawabata evaluation system, or 4 different instruments are there. One instrument for bending, the other instrument for shear and tensile, both are given in the same by the same instrument, and we have one compression tester and we have the surface roughness tester which gives the coefficient of friction, that is MIU, then MMD is the variation of friction, then SMD is the surface roughness. And the interpretation of some of these properties is also very simple. As far as the tensile properties are concerned, any increase in tensile properties is welcome. But for bending, a lower value is desirable, for shear a lower value, surface friction a lower value. And so based on the information provided by the Kawabata evaluation system, it is possible for us to have a value of this THV, that is total handle value, which is a very important parameter to classify the fabrics according to their handle. In fact, mention was made of this fabric touch tester. There is a very good correlation existing between fabric touch tester and Kawabata evaluation system, which has been well established. Only thing is that this fabric touch tester includes the thermal properties, but even in Kawabata evaluation system, that is what is called a thermal above attachment, which gives the thermal conductivity and also air permeability and Qmax, that is warm cool feeling. There are many other instruments which give this information. Alambita instrument is there, and any instrument can be used which gives the same effect. And the effect of certain treatments on the thermal conductivity has also been investigated. For example, for denim, this bleaching to start with, and also this stone washing treatment and any enzyme washing treatments on the thermal conductivity, they have been very carefully studied using this Allen-Beta tester. And we will spend some time on the fabric research, which will be very useful for designing. I mentioned to you about this fabric structure. A fabric has got a structure. A fabric can be a two-dimensional fabric, that is the length and the width, or three-dimensional fabric in addition to the length and the width, the thickness also. In fact, we use three-dimensional fabrics for certain industrial applications like radome. But the fabrics that we wear have the two-dimensional structure, and we have already seen the structures of these fabrics. This is the so-called a plain weave, which is used to a very large extent because of the fact that it is a balanced one and it gives a higher strength, but lacks in so many other respects, which we will see. Then we have a twill weave. This is the two up, two down twill. And this is the satin weave. Five and satin. And if you look at the satin weave, the one end is there, it goes behind 4 picks. That means there is a big float in the weft direction. So also here there is a big float. There is a float here, there is a big float here. Here there is no float. And we used to call these fabrics by names such as plain and twill. But when we used that term twill, there were so many questions. Which type of wool are you referring to? Whether it is 3 up, 1 down, or 2 up, 2 down, or 4 up, 1 down, or 1 up, 2 down, then there was a little bit of confusion about it. As far as the plain weave is concerned, it is perfect. There is no other weave except this plain weave. And satin also, whether you are referring to 8-end satin or 10-end satin, irregular twill or regular twill, there is no such term in the case of the plain weave. There is no irregular plain or plain, regular plain, only one plain. So there are other weaves like Dyes weave is there, Huckaback, then honeycomb, Brighton honeycomb, Mocklino weaves, Lino weaves, and so many others. Then if we want to relate the structure of the fabrics to the various properties, in order to find out their suitability, how do we proceed? That is the question that is being posed. To answer these questions, we have very useful contributions made by Matsudaira of Kanazawa University, Japan, and another gentleman who gave us the concept of this F. Then Matsudaira gave us the concept of CFF and FYF. CFF stands for crossing fiber factor. FIF stands for fabric floating yarn factor. FIF stands for floating yarn factor. How these are calculated? So there is 1 up and 1 down here. So this is one repeat. The same thing is repeated everywhere. So here we give 2, 2, 2, 8 divided by 4. So 2 is called the CFF. And FIF is 0 because it has been found that the sum of CFF and FIF is equal to 2. So when CFF is 2, this is 0, is equal to 2. And for twill, this is a repeat. So this is 2 CFF is 1, FIF is 1. Like that, we can calculate the values of CFF and FIF for various views and put them down. And one interesting aspect is that these parameters CFF, that is crossing fiber factor and also floating yarn factor, do not depend on the number of ends per centimeter or fabric set picks per centimeter. It is only dependent on the structure. So whatever may be the constructional parameters of the fabric, the values of CFF and FIF for them will be the same, and it is very simple to calculate. Having calculated that, suppose we measure their air permeability or tensile properties or Kawabata handle properties. It is possible to work out the relation between the structure and the properties. And it has been found that there is a very good correlation between the structure, that is CFF, and bending. The bending rigidity is higher in the case of plain, and with the floats it is less. So whenever there is a need for a fabric which should have a low bending rigidity, then the answer to that question is go in for not plain weave but non-plain weaves. So also shear, there is a good correlation between the CFF and shear, a negative correlation. That means when the CFF is higher, the shear values are, I think there is a positive correlation, the values are quite high, and as CFF decreases, the shear rigidity decreases. So Matsudaira carried out a very extensive study on the effect of fabric structure on various properties such as the tensile properties, bending properties, shear properties, and total handle value, and he established various the relationship between the various parameters and the mechanical properties, and also came out with prediction equations by multiple linear regression analysis. So using this formula, the mechanical properties of the fabrics can be calculated using the information on structure. And another parameter that has been developed is called FFF, that is floating yarn fabric firmness factor, fabric firmness factor. So using this, it has been found that it has got a very good correlation with the mechanical properties. So designing of the fabric is possible with the aid of these various parameters. And so far only limited work has been done with a few structures such as plain, twill, satin, huckaback, Brighton honeycomb, then the honeycomb fabrics, but a lot of work remains to be done for carrying out work with other structures in order to establish a relationship between the structure and the property. In fact, structure property correlation has attracted the attention of so many workers. It has been done in the case of fibers. A fiber which has got a higher orientation, even among the cottons, gives a higher strength. So there is a positive correlation between orientation and strength. Then crystallinity, higher the crystallinity or the packing of the molecules inside the fiber, the greater the strength. So, even in the case of the yarn, the twist in the yarn, the packing density in the yarn and its relationship to the strength of the yarns have been studied by a very large number of research workers. And in the case of the fabrics, the effect of fabric weight on strength, effect of thickness on strength, effect of porosity on strength, and now effect of structure on the strength. In fact, the structure also has got a very good effect on some of the properties like ultraviolet protection factor. We need this property for protecting us from the sun rays, which have a considerable amount of this ultraviolet light coming out of that. So when they attack the skin, we tend to get cancer, which is called skin cancer. So in order to avoid this one, fabrics have been provided with a particular finish using nanoparticles. For example, zinc nanoparticles or titanium nanoparticles can be used. And when we conducted studies on fabrics which differed only in structure, but identical in all other respects like fabric weight, thickness, etc., it was found that the fabrics which had a larger number of floats had very good resistance towards this ultraviolet protection factor. In fact, plain weave, although it has got good strength, is not suitable for certain other applications like this ultraviolet protection factor and this air permeability and all that. And also this these structures are particularly CFF and FIF are independent of the finishes or the number of ends and picks in the fabric. Assuming that a mill is making about 40 qualities and they want to distinguish between various qualities, going by the CFF will be of great advantage because they can classify the fabrics according to CFF. CFF2 means plain, CFF1 means say twill, and for sateen it is about 0.5 and 1.5 is FIF. So the total is 2. So these parameters help us in classifying the fabrics for marketing purposes. So the contributions that have been made by Matsudaira, we should say that, are very helpful, and Matsudaira's contribution is a milestone, so to say, in fabric studies. We were talking about the contributions made by Matsudaira in evolving the parameters such as CFF and FIF, and Millasius is another gentleman who came out with a parameter called fabric firmness factor. This fabric firmness factor is calculated from the set of the fabric, the density of the fiber, the weight. So it involves several steps. And calculation of fabric firmness factor is a little complicated as compared to CFF and FIF. We need a computer for getting the V factor. So there are 7 factors which are to be obtained for calculating this fabric firmness factor. And but it has got a very good correlation with CFF. In fact, for plain weave CFF is maximum, that is equal to 2, and for the same fabric Millasius FFF is also the highest one. So the relationship between this FFF and CFF is almost linear, and the correlation is about 0.99, which is excellent. So one is complementary to the other. But then the V factor is also found to have an effect on many of the fabric properties, which is included in this fabric firmness factor. So there are 7 parameters which are required for calculating this fabric firmness factor. And fabric firmness factor has been found to be well correlated with the tensile strength and with air permeability, flammability of fabric, and fabric firmness factor is dependent on set. That means if the number of picks are more, then the V factor also, this fabric firmness factor also will be different. Whereas CFF is unaffected by the fabric set, whereas FFF is influenced by the fabric set. So in that way, it is also desirable to get these FFF, because if fabrics are made with different number of picks per centimeter or different set, then FFF will clearly reflect the changes that have occurred in the fabric structure. And this FFF has been correlated with air permeability. Air permeability is a very important parameter because low air permeability means better thermal insulation, because it will not allow air to pass through. So the heat will not be allowed to pass through and it will be retained. So that is what is called thermal insulation. So air permeability has been found to be affected by these V parameters, namely CFF and FFF. A number of studies have been made by using these parameters for correlating them with the fabric properties. And what comes to our mind is that when fabrics are subjected to wet processing, such as, let us say, scouring or mercerizing, then dyeing, then resin finishing, all these will have an effect on the fabric handle as well as on the correlation between these V parameters and the structure. Because when fabrics are subjected to wet processing treatments, their consolidation improves a lot. That means the air permeability will be reduced because of the closing together of the warp and weft yarns due to shrinkage, and that will affect the values of this CFF and also FFF. So if for a fabric CFF is determined before bleaching and after bleaching, the values will be different. So also after resin finishing, the values will be different. So most of the wet processing treatments have got a very significant effect on CFF and FFF, and bearing these points in mind, any correlation between the weave structures and the mechanical properties should be attempted. And the parameters, namely CFF and FFF, are available only for a few fabrics. That means with different weaves, but there are so many other weaves like Bedford cord, then PK, then the warp, extra warp fabrics, extra weft effects and all that, double cloth. So for all these, the computation of these parameters CFF and FFF may be very desirable in order to have a relationship between the fabric structure and also the mechanical properties. No attempt has been made to find out the effect of these V parameters on sewability, on seam strength or seam efficiency, and it will be desirable to carry out further studies on these aspects to have a complete understanding of the role played by these V parameters on sewability. And further work also has been done, as I mentioned, on the effect of weave structures on YMMC. In fact, for plain weave it has been found that it is the lowest one, and when fabrics with floats like sateen and twill are tested for YMMC, the values are higher. So that shows that the weave has got a very significant effect on the comfort characteristics, because if YMMC value is greater than 0.8, it is considered to be excellent. So the effect of weave structures on YMMC also has been investigated. As such, that is in the bleached state, and also after treatment with zinc nanoparticles. Now, following treatment with the zinc nanoparticles, it has been found that the value of YMMC has reduced, indicating that the fabrics have become somewhat water repellent, that means not water absorbing. So, YMMC values are found to be quite sensitive to the finishing treatments that have been applied to the fabrics. And to what extent the other finishes such as crease resistant finishes or this biopolishing or treatment with enzymes remains to be seen, and that is the scope for further research on the fabric studies. That means having fabrics with different weaves and different finishing treatments, the effect of these two combined effect, that is finishes or the parameters on these YMMC, will be a very interesting study. Then fabric touch tester also, it will be better to carry out work with fabric touch tester. In fact, Professor Hugh, who developed this YMMC somewhere in the year 2005, also developed this fabric touch tester. So the credit goes to the Hong Kong Polytechnic department for having given to the industry these two testing instruments, one for assessing the comfort, the other everything concerned with the skin and the fabric effect. That is what the fabric touch tester tries to give an information, and already a lot of data are available on this YMMC and fabric touch tester, but it will be better to re-examine the effect of all these parameters on this YMMC. And another thing that has been done is the effect of nano finishers on antimicrobial effect. Here also a number of dyes have been identified which have both the effect of dyeing the fabric as well as for conferring this antimicrobial effect. So dual action is expected of a natural dye having both these characteristics. One such example is the red sandalwood, which has been explored for fabrics. Not only this provides the antibacterial effect, because sandalwood has got this property, it also gives a pleasant smell or the aroma for the fabric, which improves the marketability of the fabric. So some studies have already been carried out using this red sandalwood on the dyeability and also on the antimicrobial effect of the fabrics, but some more studies are desirable in that direction. And the effect of weave structures on air permeability also has been examined in depth. The previous research workers neglected the parameters such as porosity and thickness in their studies. But when these parameters were included along with the weave structures, a different picture was obtained altogether, and the dependence of air permeability on some of these factors could be studied with great care. So that was the benefit of carrying out this work. Then on knitted fabrics, a lot of studies have been done, particularly with reference to UPF, that is resistance towards ultraviolet factor. UVF, ultraviolet factor. And a very detailed study has been carried out at Hong Kong Polytechnic by Wang and Pozzel. and they have come out with a conclusion that the knitted fabric structure has got a profound effect on these ultraviolet protection factor, UPF. Today, in addition to wearing the fabric, if the fabric possesses such properties such as the UPF, it is most desirable, and that enhances the value of the clothing today. And standards have been provided for assessing this ultraviolet protection factor for various categories and all, and instruments which are used for determining this ultraviolet protection factor also have been advanced a lot, so that the precision of the instrument is improved, the values obtained from that. So, and another thing that should be discussed is the protective clothing. In fact, when we talk about the protective clothing, it goes without saying that it should have a good UPF, that is ultraviolet protection factor, and also antimicrobial effect. Now, there are two ways of conferring to the fabric this antimicrobial effect. One is using the nanoparticles, the other is using plasma treatment, low temperature plasma treatment have been exploited. And plasma is a gas which makes a lot of differences on the surface of the fabrics. The embrittlement takes place when the textile fiber is exposed to this plasma, and it shows an improvement in the air permeability and also in water absorption in YMMC and in so many other aspects, and it is a treatment which does not involve any effluent. So, the merits of the plasma treatment are quite obvious compared to any other wet treatment. Then protective fabrics, we have the life-saving devices. For a soldier who goes inside the sea, that is submarines and high altitude. So, a lot of protective clothing which incorporate these flame retardant characteristics have been developed and they are being assessed. Usually they are all made out of very expensive fibers like Kevlar, then Nomex, Dyneema. So today, with the introduction of several new types of fibers, the properties of these protected garments also have shown a considerable improvement. And in fact, some of the fibers which have been developed recently are exclusively meant for the protective clothing. Protective clothing also includes cut resistant fabric. So they are eminently suitable for gloves, and while working on some of the machines or cutting some of these machine tools and all that, it protects the hands. So wearing the gloves which have this cut resistant property will go a long way in improving our life and also the health care and so many other things and all. And as I was mentioning, the fabrics are also being developed for various health care problems, namely incontinence and pads. In fact, the development of pads, which are hygienic materials from the spun bonded nonwoven and other types of nonwoven fabrics, is itself a great development, I should say. And some of the important properties of the pads are the frictional properties between the pad and the skin. It should not cause any irritation. So, in a very systematic way, the frictional properties of the pad and the skin have been determined for different types of these pads, and the relationship between the various types of the pads and the frictional properties have also been studied in great depth. In foreign countries, there are projects which are earmarked for this area, that is this health care, and also the fabrics which are used for making some of the lingerie items like warp knitted fabrics, they are also being studied with great care in order to see whether they have any undesirable effect on the ladies who wear them, so that by way of increased compression or high friction and all that, so that the attention can be paid to those areas where further development is required. So when we talk about the fabric studies, a very good amount of research has been done in the recent times to improve the health care and also to recommend certain measures which are to be taken for avoiding the skin cancer. For example, the finishes which improve these ultraviolet protection factor, namely nanoparticles. So the use of the nanoparticles has become quite widespread in the industry today, and we hope that in a few years some more improvements will be achieved in fabric health care. Let us talk about this yarn and how it is made. We have already discussed the properties of the fibers from which the yarns are made. Let us say cotton or polyester, or blends polyester and cotton. Now, when we talk about the yarns, there are so many types of yarns. Filament yarns, textured yarns, then spun yarns. In spun yarns, a single component, say cotton, or polyester and cotton, or polyester and viscose, or polyester and wool. And the terminology, carded yarns, combed yarns, doubled yarns, plied yarns, and so many other types of yarns like rotor yarns, dreft yarns, or composite yarns. And another category is the conventional and compact. See, over the last years, the ring frame was used for producing yarns, that is either corded yarns or combed yarns. And people thought that it had reached a saturation point beyond which nothing could be done. But you know what happened? The compact yarn came into the existence. It was found that in the ring frame, not all the fibers were contributing to the strength of the yarn, and fibers were not being gripped by the yarn structure. So they carried out some investigation on the spinning triangle, that is the material after it emerges of the front roller forms into a triangle. So by narrowing this triangle or reducing the area, they found that the edge fibers also could contribute to the strength of the yarn, and that was the principal reason which made them to develop these compact yarns. This compaction can be achieved by two means. One is mechanical, the other is by air suction, that is called pneumatic. So different types of compact systems were developed. Susan, then Rieter, and Rocos, which is a mechanical type of compacting system. And this Rocos has got one advantage, that if it is not required, it can be removed, and if it is required, it can be fixed onto the ring frame for the production of compact yarns. And the merits of the compact yarn were claimed as less hairiness, then more strength, less number of imperfections, and as a result of that, the fabric that is produced will be very clean and it will have a good appearance, and all these claims were found to be quite true, and many materials were processed on this compact spinning. For example, 100% cotton, then polyester cotton, polyester viscose, and it was found that there was a considerable improvement in the yarn quality. Let us have a look at the spinning organization first. The spinning organization consists of the process and also the speeds that are being used, and a cursory look at them will give you a very interesting information. But first let us see from 100% cotton how the yarn is produced. Blow room, then carding, then two passages of drop frame, break and drop frame, finisher drop frame, and speed frame, then ring spinning. Either it may be conventional or compact. And when you look at the hank of the material, that is lap is the, here the input is a cotton, the output is a lap which has got a hank of 0.0014. Here lap is the input and sliver is the output, and the sliver hank is 0.14. Breaker drop frame, finisher drop frame, it is all 0.14, and in speed frame it is 1.4, and in spinning it is 30s. Now what does it show? When the hank is 0.0014, it is very coarse, that is very thick. Then it is thinned out to 0.14, almost about 100 times or so. Then the same hank is maintained in the drop frame, but in the speed frame you find that there is a 10 of a drop, that means the material is thinned out. Then further thinning takes place in the ring frame to 30s, and twist is also given. The twist we represent it by a twist factor, 3.4 of a twist factor. So there is a simple formula which connects TPI in the yarn to twist factor, that is K into root of C. So K is 3.4 and root of C is 30s in the English cotton count. So assuming that it is about 5 point something, so you get about 18 to 19 of a twist per inch. That is how it is estimated. Or the twist per meter can be around 800. This can be calculated. It is always better to give the twist per meter for the yarns which are produced, and if different counts are produced, better to give the twist per meter for different counts. And the process of thinning down is called drafting. From 0.0014 it is thinned out to 0.14 and to 1.4 and 30s. So this is so called, this flow chart tells you about spinning and the various drafts that are used, and the various hanks that are being kept in the various departments also affect their production. If a coarser hank is maintained, then production is high, and if a finer hank is maintained, the production is lower. So depending on their quality and the type of machinery they have, all these are being set. Now let us have a look at the speeds of the machine approximately. Now for 100% cotton yarn, we mentioned that in the blow room, the hank is 0.0014 and the delivery speed in meters per minute, that is the terminology that is used for representing the output, is about 7 meters per minute. And carding 0.14, it is 150 meters per minute. Then draw frame 0.14, 600 meters per minute. Speed frame 0.14, 15 meters per minute. Then ring frame 30s, it is 1.4. This is the output tank. 30s count, it is 15 meters per minute. Now it is very interesting to see that before the spinning, all the machines have very good production. Now, blow room, you might think that 7 meters per minute is the lowest one, but when you think about the thickness of the lap and the dimensions, this is quite high. And carding, compared to carding, draw frame speeds are quite high, almost about 4 times. But when it comes to the ring frame, speed frame and ring frame, it is reduced almost about say 40 times or so. That means the ratio is 40, 600 divided by 15. Here also it is 40. So what does it show? As we proceed from blow room till ring frame, the number of workers in the blow room are less, but in the ring frame they are very high. So the labor complement in the ring frame is quite high to produce a certain output, and that is because of the fact that the yarns are produced which are given twist, and that is the end product. Of course, for marketing, there is another process which the yarn undergoes called cone winding, and the yarn is marketed in the form of a cone to two sectors. One is knitting, the other is weaving. Of course, cones are dyed also in certain cases and sent for weaving. And whatever may be the count, it is an accepted fact that the production in the ring frame is 15 to 20 meters per minute. And today, everybody says that the production is to be improved. We want a higher output. That is what is called as the supply chain management in the spinning mill. It means that the lead time has to be reduced. Let us say that somebody quotes some 20 days for supplying 20,000 kilos of 30s yarn, and if a mill can do that in 10 days, the people will go into that mill for taking the yarn because of the lower lead time, and quickly the fabrics also can be produced and then they can be converted to the garments. So that is what is called a lead time in the spinning mills. That is, the time takes a cotton takes to be converted to a yarn and then to be marketed. But supply chain has got the definition of converting anything to a product and then to market it. So all these processes take some time, and the production in the ring frame cannot be increased beyond this 15 to 20 meters per minute. And high speed spinning has been resorted to, but it has been found that when speeds are kept beyond a certain limit, then it is detrimental. There will be very high end breaks, and then the quality of the yarn also will be very poor. So one has to strike a balance between all these parameters. In fact, there are only two factors which affect the strength of the yarn. One is the twist, the other is the spindle speed. So when speeds are increased, production will be increased. When twist is reduced, production will be increased. But then the quality has to be looked into. A reduction in twist is required in knitting yarns, but not in yarns meant for weaving. The yarns meant for weaving should have a very good strength in order to have good resistance towards these tensions which are imposed in the various processes such as cone winding, warping, weaving, sizing, etc. So this table gives you an idea about the production speeds which are maintained in various departments. And for combed counts, there is one change. After the carding, we can have draw frame and lap former, then comber, which is an additional process. The comber is meant for removing the short fibers from the cotton and to make the material more uniform. And two draw frame passages after the comber, then simplex and ring frame. Then after ring frame, cone winding, doubler winding, doubling, then marketing. In fact, marketing of doubled yarns is found to be quite useful in the sense that doubling is a value addition process. Dyeing is a value addition process. If a cone is dyed, it can be sold at a higher price because of the color that it contains. And colored yarns are required in qualities such as stripe shirting, check shirting, etc. And a check shirt costs much more than a white shirt, and also a striped shirt also costs a lot. But then people are attracted by their design, and then they don't mind to spend a lot of money in buying them, and they are quite expensive. So we have to cater to that market as well. And there is also another change. Suppose the mill has got, after the card, it goes to a sliver lap machine, ribbon lap machine, and then comber and draw frame, and simplex and ring frame. Then combing also can be, doubling also can be done, either by a 2-for-1 twister or a doubling machine, as the case may be. A 2-for-1 twister means for every one turn, two turns of twist are inserted in the yarn, which are quite economical. Now compact yarn. Now the yarns are tested, and for marketing purposes certain properties are required in order to take a decision whether to buy the yarn or not. See, generally we get a yarn test report or yarn characteristics. Say tenacity in centinewton per tex, elongation, in percentage, then U%, that is the uniformity, thin, thick, NEPS per kilometer, then abrasion resistance, then hairiness, friction. These are all defects in the yarn. Thick, thick NEPS U% refers to the uniformity of the yarn, elongation is elongation yarn. These are very desirable characteristics, hairiness. Now when we compare a conventional yarn with that of a compact yarn, we find that there are improvements in tenacity, elongation, and in particular hairiness will be much less. Hairiness is nothing but the protruding fibers on the yarn. If there are more protruding fibers, then processing becomes difficult, and the appearance of the fabric also will be impaired. So producing a yarn with less hairiness is an advantage even for the knitted fabric. In fact, prior to knitting, singeing of the yarns is advocated in order to see that the protruding hairs are removed. Singeing means passing the yarn through a burner to see that the protruding hairs are burnt out and the yarn becomes smooth. So hairiness has got a lot to do with the knitting of the fabrics and also of the woven fabrics as well. A lot of studies also have been done to illustrate the importance of this hairiness on the fabric appearance. Then friction. For knitting yarn, this is very important. In some cases, the waxing process is also applied to the yarn prior to knitting in order to see that when the yarn passes through the latch needle, the friction is reduced. So friction plays a very important role in knitting and also in weaving. In fact, some mills used to give after waxing treatment after the sizing is over. After waxing, the idea is to reduce the friction. It is not known whether this is now prevalent or has been discontinued. So when we get a report like this, we are in a position to see the performance of the yarn, how best is the yarn, and take a decision for purchasing that for a particular item like shirting or a knitted fabric, or see, for suiting we use doubled yarns. So generally doubled yarns are not tested for so many properties because they are supposed to be uniform. When one yarn is combined with another yarn, most of the irregularities or hairiness, they are all suppressed. So a doubled yarn is superior to a single yarn. In fact, in knitting only single yarns are used, double yarns are not used, whereas in weaving double yarns are used for suiting. For certain type of shirting also two-fold yarns are used, but in suiting invariably two-fold yarns are used. And as I said, that doubling is a value addition process. It improves the performance of the yarn. In fact, if doubled yarns are used for the production of fabrics, there is no need to give sizing also, and some mills avoided giving sizing treatment to these yarns, and it is an advantage also because when sizing is given, after some process, desizing has to be given to the fabric. That means an additional process. But it is a debatable point whether sizing is to be given or it can be eliminated. So it is all depending on the mill's view and what they have in their mind. But double yarns are used in suitings. Most of the suitings, 100% suitings, whether it is polyester cotton or polyester wool or polyester viscose, double yarns are used. And we make different types of yarns, carded and combed. Usually for knitting, combed yarns are preferred, having a twist factor of 3.3. A very low twist factor for knitting yarn is recommended because if fabrics are made out of them, knitted fabrics in particular, they will be soft. Otherwise, the fabric feel will be very harsh. So that is the reason why low twist yarns are preferred. In fact, low twist yarns also improve dyeability. And there is a defect in knitted fabric called spirality, which is avoided by using low twist yarn. So the Hong Kong Polytechnic did a very comprehensive work on these low twist yarns or low torque yarns as they are called. They fixed an attachment to the ring frame in order to produce a low torque yarns. And the potential of these low torque yarns was studied in fabrics like denim, and also their dyeability was assessed. Knitted fabrics were made from the normal yarns and also the low torque yarns, and the spirality that is present in the fabric made from a conventional yarn vis-a-vis a low torque yarn was investigated, and they found that there was a considerable improvement in spirality. That means reduction of spirality was noticed. So it has been well established that a low torque yarn is beneficial to improve the dyeability and also the appearance, and also reduce the defect, namely spirality, in the knitted fabric. And in that way, the modifications that have been made to these yarns have resulted in considerable improvement in the appearance of the fabric and also in the efficiency. So, lot of research which has been carried out on the yarns, or rather is oriented towards improving the performance of the fabric. Then on fabric, what are all the properties that are required in order to judge that fabric is good? Today we have got instruments which are capable of measuring their comfort, handle, touch. Previously, all these were measured subjectively by just feeling the fabric. Oh, it's good, it is soft. But it may be misleading in the sense that if our hand is a little wet, then whatever decision that we take will be wrong. And this is called objective test. That means we use instruments to get the handle and the touch and also the moisture, that is liquid transmission property. So in that way, reproducibility is possible and operative error is very much avoided. So instruments have been developed today to find out various characteristics of the fabrics which were earlier determined by using subjective methods like feeling the fabric or finding out the comfort of that. And so many finishing techniques have come today which require proper testing of the fabric at the end to see that that particular treatment has been found to be effective. For example, flame retardant fabric. Then fibers with different cross sections are available today. There are fibers which are meant for providing more comfort, say with a different cross sectional shape, and they have been used for making the yarns and ultimately the fabrics, and they were tested for various properties which represent their comfort characteristics. It was found that whatever claims that the fiber manufacturers have made have come true. So fiber modification, then yarn modification, that is low torque yarns, then fabrics with different finishes. In fact, finishes will make a lot of changes in the fabric appearance. For example, there is a process called brushing, about which some information was given earlier, or polishing, or sand wash. This sand wash is very common for knitted fabric to convert that to a flannel like thing. We talked about the flannel also in one of our lectures. Very soft substance, and it improves the moisture absorption. So this is a mechanical finishing process, and it is advantageous to the fabric in the sense that its absorbency is considerably improved. So in fabric studies, we have talked about the various types of yarns, and coming to the compact yarns. In what way a compact yarn is superior when compared to a conventional yarn in terms of tenacity, in terms of elongation, in the imperfections, in abrasion resistance, also in hairiness. In fact, one very interesting observation that has been made is, if a fabric is made from a conventional yarn and from a compact yarn, in the compact yarn the air permeability is higher because the yarns are more compact, they allow more air, that is breathability is good, or the comfort is enhanced when compact yarns are used in the fabric vis-a-vis the conventional yarns. So we have found that most of the improvements that have been made in spinning, particularly the compaction, and even in the compaction, it is possible to produce a two-fold yarn in the ring frame, so that production of a double yarn is avoided. Earlier, this was called as gyro spinning, feeding two rovings in the ring frame and getting them drafted separately and then combining them to produce a so-called doubled yarn. But with compact spinning arrangement also, it is possible to produce a yarn with two strands. So these yarns or most suited for the production of suitings. So the technology has been improved so much today by reducing this hairiness and also by improving the tenacity and the elongation, and all this has resulted in an improvement in the fabric appearance. Ring spinning is a very versatile method of spinning the yarn, as different counts starting from 8s onwards even up to 300, 400 can be spun, and it is a very cheap form of spinning the yarn, and it has been used over centuries for the production of yarns. Side by side, several developments in the yarn production have occurred, principally for improving the production of yarn. For example, the production of yarn in ring spinning was mentioned as 15 meters per minute. If something could be done to increase this to 250 or 400, then production would be quite high, and this will also have a repercussion on the number of laborers employed, lead time, etc. And the first spun yarn production, which was quite different from the ring frame that was made, was rotor spinning. It started with vortex yarns and then with rotors. Unfortunately, the yarns were found to have very poor strength, and they had wrappers on the surface. The structure was quite different, and although the production speeds were of the order of more than 150, but the yarn quality and also the number of counts that could be spun were also quite limited. All these precluded the industry to progress further, and even today ring spinning has dominated the spinning industry because of its versatility. And there were other spinning systems which were developed, for example, air jet spinning and the drift spinning. Although these systems were quite productive, unfortunately, only certain types of yarns which are required for certain end products were produced or could be produced using these systems. Then this air jet spinning was introduced. Here the input is a sliver and it passes through this machine. There are two nozzles, one rotating in the S direction, the other rotating in the Z direction, and a yarn is obtained. This yarn had very poor strength of 6 gram per tex strength, and some improvements were made by making certain modifications in the air jet spinning with a view to improving the quality. But today air jet spinning has not kept pace with ring spinning technique. And in air jet spinning, the slubber or the simplex is eliminated because the cotton is fed into the machine in the form of sliver rather than a roving. Large tubs of stock taken from the drawing process to the spinning department reduce manual handling. The yarn discharging from the spinning head can be wound directly onto spools to eliminate the need of a winding operation. So that is the advantage. Even in the rotor spinning, this facility is there of winding the yarn onto a spool, so that further winding, like in the case of the ring yarn, could be eliminated. Another point is that air jet spinning requires a very clean cotton with a long staple length. Usually the cotton sliver goes through a 3-step drawing operation. Air jet spinning frames use a rotating disc to convert cotton sliver to yarn. The tubs of sliver are loaded down each side of the frame. As the sliver feeds through faster and faster sets of rollers, the sliver reduces in bulk. The spinning action occurs between the last roller grip and the spinning disc. Plastic starter bobbins containing a small amount of yarn are stored at one end of the frame. As the starter bobbins are automatically fed onto the machine, a movable splicer picks up the starter yarn and splices it to the newly produced yarn tab at one end of the numerous spinning stations on the frame. Well, a splicer is one thing which joins the broken ends of the yarn and it avoids putting the knot, and the splicer works on the suction principle, and the very fact that the knots are not put will be advantageous because the knots are get caught in the reed of the weaving that loom, and then it may result in a break. So splicers are found to be beneficial, and most of these cone winders today are equipped with this facility of putting these splicers in the yarn whenever there is a breakage. When the bobbin is full, it is automatically removed and replaced with a new starter bobbin. Full bobbins are discharged onto an open conveyor at the center of the machine. Heat and air are exhausted through a filter unit at each end of the center conveyor area on the machine, producing an air wash which removes fine lint. The fundamental difference between air jet spinning and rotor spinning is that air jet spinning is a false twist method, while rotor spinning requires a complete separation of fibers, and ring spinning requires a complete continuity of fiber flow. Air jet spinning requires partial separation of the fibers. Similar to rotor spinning, the input strand in air jet spinning is a drawn sliver that may be carded or combed. Drafting is achieved using high roller drafting to reduce the size of the input sliver to the desired yarn size. The binding mechanism is achieved by blowing compressed air through two nozzles to form an air vortex. One is the end opening nozzle and the other the twisting nozzle. The yarns produced are twisted in one direction. Very fine yarns cannot be run on this spinning system because strength imparted to the yarn is not enough to withstand the rigors of further processing. Some of these machines use a two sliver input. The slivers are drafted through the equipment to a dual head spinning nozzle which spins the yarn in opposite directions. The two yarns are then brought together and create a 2-for-1 twisted yarn. The yarn passes through a yarn cleaner and a waxing device before it is packaged. The process produces a relaxed yarn with about the same tensile strength as ring spun yarn. Some of these machines use a two sliver input. If only the twisting nozzle is working, this will result in pure false twisting the fibers and forming a yarn. However, when the yarn leaves the nozzle, untwisting takes place. In the actual machine, the two nozzles apply air rotation in two opposite directions, with one nozzle imparting a higher rotational speed, avoiding complete false twisting. The resulting twist is the difference of the two imparted twists. In the fiber strand, the twisted core will immediately tend to untwist and the detached fibers will wrap around the core fibers. These result in a yarn consisting of a core of parallel fibers wrapped at some points along its length with fiber wrappers. The primary source of strength of air jet spun yarns results from effective fiber wrapping. as I pointed out, sliver is the input in air jet spinning and yarn is the output. Whereas in the case of the ring frame, the roving is the input and yarn is the output. And in rotor spinning, sliver is the input and yarn is the output. So in a way, air jet spinning and rotor spinning are identical or similar, and this air jet spinning gives an output of around 350 to 450 meters per minute, whereas ring spinning is 15 to 25 meters and rotor spinning is about 250. So the output is quite high in the case of air jet spinning, and this air jet spinning was used for producing sewing thread from 100% polyester. But the sewing thread that was produced using the ring spun yarn was found to be superior when compared to this air jet yarn, and so people have discarded this air jet spinning for the production of the sewing thread now, and they have switched over to ring spinning technique. So although various spinning techniques have been introduced, such as rotor spinning, then this air jet spinning, and DREF. DREF is nothing but producing yarns by friction twisting, and very coarser yarns have been produced using that. Even core yarn was produced. They were all used for fabrics which are used in technical textiles, these DREF yarns. DREF is a name because Dr. Ernst Farrer developed this, so the spinning system is named after him, Farrer. But the compact system, which was introduced some 15 years ago, has become very popular today because of the improvements that have been achieved in the yarn, the less airiness, higher strength and very good appearance for the fabrics. Many shirts have been made using these compact yarns, and they have been sold at a higher prices, and even in the label, compact yarn made, one can see that. So the compact spinning has made a very high impact, I should say, when compared to this air jet spinning and other technologies. And moreover, a compact spinning can be fitted onto a ring frame, and Rocos, I told you, can be removed or fitted. It is called retrofitted. Retrofitted means as and when we like, we can fit that attachment and then produce a yarn, and if not required, it can be removed also. That facility is available with this Rocos spinning. And Barotta air jet spun yarns today have not become so popular, and maybe there may be better spinning systems which may come in the market tomorrow for the production of the yarns.